Hi everyone, welcome to Alpha Beta Tutorials. In this video, I am going to take you through Wassce 2021 Physics Practical. Alternative A. Question 1. A question under light. Without wasting time, let's go straight to the physics lab and start. You are provided with an illuminated object. A lens. A screen. A lens holder. And a meter rule. Use the diagram above as a guide to perform the experiment. Determine the approximate focal length, f, of the lens by focusing a distant object on the screen. We have this distant object at this part of the lens. We are going to adjust the distance between the lens and the screen until we obtain a sharp image of the distant object on the screen. We measure the distance between the screen and the center mark of the lens holder. It's 15 centimeters, and that is the focal length of the lens. The instruction at this part of the question is to place the illuminated object and screen at a distance of 100 centimeters apart, which is the full length of the meter rule, and name the distance capital D. Place the lens at a position S1 to obtain a sharp image of the object on the screen. Note S1. S1 is the distance between the ray box and the center mark of the lens holder, which is 19.4 centimeters. Move the lens to a position S2 to obtain another sharp image of the object on the screen. Note S2. We have a sharp image on the screen but is too small to be captured clearly by the camera, even though the naked eyes can see it clearly. S2 is the distance between the ray box and the center mark of the lens holder, which is 82.6 centimeters. Measure the distance, D, between S1 and S2. The distance between S1 and S2 can be found by subtracting S1 from S2. 82.6 centimeters minus 19.4 centimeters is 63.2 centimeters. Evaluate capital D inverse, capital D square, small d square and small d square over capital D square. For capital D inverse, we have 1 divided by 100, which is 0.01 per centimeters. For capital D square, we have 100 square, which is 10,000 centimeters square. For small d square, we have 63.2 square, which is 3,994.24 centimeters square. For small d square over capital D square, we have 3,994.24 divided by 10,000, which is 0.3994. Small d square over capital D square has no unit, since centimeter square will cancel out. Repeat the procedure for 4 other values of capital D is equal to 90 centimeters, 85 centimeters, 80 centimeters, and 70 centimeters. In each case, evaluate capital D inverse, capital D square, small d square and small d square over capital D square. So we are going to place the illuminated object and screen at a distance of 90 centimeters apart. Move the lens to locate two sharp images S1 and S2, find the difference small d between S1 and S2, evaluate capital D inverse that is 1 divided by 90. Evaluate capital D square that is 90 square. Evaluate small d square and small d square over capital D square. Repeat the same procedure for capital D is equal to 85 centimeters, 80 centimeters, and 70 centimeters. And fill the table. Plot a graph with capital D square over small d square on the vertical axis, and capital D inverse on the horizontal axis. We have to change the values to standard form, for easy plotting. For small d square over capital D square, we move the decimal point 4 times to the right. 1, 2, 3, 4. So we have 3994 times 10 exponent negative 4. For the rest of the values, we have 3338, 2941, 2500, and 1433, each value times 10 exponent negative 4. Similarly, for the first value for D inverse, we move the decimal point 4 times to the right. 1, 2, 3, 4. So we have 100 times 10 exponent negative 4. For the rest of the values, we have 111, 118, 125, and 143, each value times 10 exponent negative 4. We are going to plot a graph of small d square over capital D square on the vertical axis, and capital D inverse on the horizontal axis. We will choose a scale of 2 cm to 500 units on the small d square over capital D square axis. Starting from 500 we have 500, 1000, 1500, 2000, and so on. We choose another scale of 2 cm to 10 per cm on the capital D inverse axis. Starting from 100, we have 100, 110, 120, 130, and so on. On the vertical axis, each big box is 500. 500 divided by 10 is 50. So each small box on the vertical axis is 50. On the horizontal axis, each big box is 10. 10 divided by 10 is 1. So each small box on the horizontal axis is 1. For the first point, we have 100 on the horizontal axis, and 3994 on the vertical axis. This is 4000, so 3994 will be within the last box, since each small box is 50. For the second point, on the horizontal axis, this is 110. So when we move one box to the right, is 111. On the vertical axis, this is 3000. When we move 6 small boxes up, is 3300. So 3338 will be within the 7th small box. For the next point, on the horizontal axis, this is 110. So we move 8 small boxes to the right, which is 118. On the vertical axis, 2941 will be within this small box. For the next point, this is 120. So we move 5 small boxes to the right for 125. On the vertical axis we have 2500 here. For the last point, on the horizontal axis, this is 140. So we move 3 small boxes to the right for 143. On the vertical axis, 1433 will be within this small box. We then draw the line of best fit. Determine the slope, S, of the graph. Let's draw this vertical and horizontal lines, and label it A, B, and C. The slope, S, is equal to change in AC, over change in AB. For change in AC, we have 3500 minus 2000. For change in AB, we have 108 minus 133. 3500 minus 2000 will give us 1500. And 108 minus 133 will give us minus 25. 1500 divided by negative 25 is negative 60. And the reciprocal of per centimeter is centimeter. Given that S is equal to 4K, determine K. Dividing through by 4, we have K is equal to S over 4. But the slope, S, is negative 60 centimeters. Negative 60 centimeters divided by 4, will give us negative 15 centimeters.